Welcome, history enthusiasts and curious minds alike. Today, we're embarking on an epic journey through time to explore one of the most fascinating aspects of ancient Roman military prowess. We're not just talking about sharp swords and shiny armor, oh no. We're diving deep into the ingenious world of Roman military engineering. Specifically, we'll uncover the secrets behind how the Roman army built bridges and forts, two key elements that were instrumental in forging one of the greatest empires in history. So, grab your pilum, fasten your larica segmentata, and let's march into the past. Picture this, you're a Roman legionary marching through unknown territories. The vast expanse of the empire stretches before you, filled with treacherous rivers, hostile lands, and unforgiving terrain. How do you overcome these obstacles? How do you establish control over newly conquered territories? The answer, my friends, lies in the remarkable engineering skills of the Roman army. You see, the might of Rome wasn't just in its fierce warriors or brilliant tactics. A huge part of their success came from their ability to rapidly build infrastructure wherever they went. Bridges allowed them to cross seemingly impassable rivers, while forts provided security and a base of operations in foreign lands. These weren't just buildings, they were the veins and arteries of the Roman war machine, pumping the lifeblood of conquest across Europe, North Africa, and the Middle East. But before we dive into the nitty-gritty, let's take a moment to appreciate the scale of what we're talking about. At its height, the Roman Empire spanned over 5 million square kilometers. That's like trying to control an area larger than the entire European Union today. And they did it without phones, computers, or even a decent postal service. Mind-boggling, isn't it? Now, let's start with bridges. You might think, how hard can it be? Just throw some logs across the river. Oh, my sweet summer child, if only it were that simple. Roman bridges were marvels of engineering that would make modern civil engineers green with envy. Take, for example, the famous bridge over the Danube, built by Emperor Trajan in 105 AD. This wasn't just any bridge, it was a statement of Roman power and engineering prowess. Stretching over a kilometer long, it was the longest arch bridge in both total and span length for more than 1,000 years. Can you imagine building something like that without power tools, advanced mathematics, or even a calculator? I get frustrated just assembling IKEA furniture. The Danube Bridge consisted of 20 piers of stone blocks, each 31 meters high and 18 meters wide, spanned by wooden arches. The whole structure was 1,135 meters long, that's about 12 football fields, 15 meters wide, and towered 19 meters above the water. It's enough to make your head spin. But how did they do it? Let's break down the Roman bridge building process. Site selection. Romans weren't fools. They chose narrow points with stable banks to minimize the bridge's length and ensure a solid foundation. Foundation laying. This was perhaps the trickiest part. They used cofferdams, watertight enclosures, pumped dry to permit construction work below the waterline. Imagine trying to keep a river at bay while you work. Pier construction. Massive stone pillars were built to support the bridge. These weren't just piles of rocks, they were carefully engineered structures designed to withstand the constant flow of water. Arch assembly. The iconic Roman arch was the key to their bridge's strength. The arch distributed weight evenly, allowing the bridges to bear enormous loads. Road surface. Finally, they'd add a smooth stone surface for easy crossing. Some bridges even had grooves carved into the stone to provide traction for horse hooves and wagon wheels. Here's where it gets really interesting. The Romans had a secret weapon in their bridge building arsenal, their incredible concrete. Roman concrete, or opus cementitium, was far superior to anything we had until the modern era. It actually gets stronger over time, especially in water. The recipe? Volcanic ash, lime, seawater, and lumps of volcanic rock. When mixed, This concoction triggered a hot chemical reaction that allowed it to set quickly, even underwater. Some scientists believe that the seawater actually interacts with the volcanic material to strengthen the concrete over time, which explains why so many Roman structures are still standing today. Speaking of which, here's a mind-blowing fact. Some Roman bridges are still in use today, 2,000 years later. The Pons Fabricius in Rome, built in 62 BC, still carries pedestrians across the Tiber River. Talk about built to last. Makes you wonder about that wobbly IKEA shelf, doesn't it? Now, let's shift gears to forts. Roman forts were like the ancient equivalent of a Swiss Army knife, multipurpose, efficient, and always ready. These weren't just simple wooden stockades. Oh no. Roman forts were complex, well-designed structures that could be rapidly deployed wherever they were needed. The most impressive aspect of Roman fort building was their speed. A typical legion could construct a marching camp, a temporary fortification, in as little as a few hours. Imagine building a secure base for 5,000 men, complete with defenses, in less time than it takes to binge-watch your favorite TV series. The process was a marvel of organization and efficiency. Site selection: high ground with good visibility. Check. Water source nearby? Double check. Defensible position? Triple check. Layout: they used a standard layout, which meant every soldier knew exactly what to do. It was like a well-choreographed dance, with each legionary playing their part. Defenses: ditches were dug, and walls were erected using local materials. The standard design called for a ditch 3 meters wide and 1.5 meters deep, with the excavated earth used to build the rampart. Internal structures, barracks, granaries, and a headquarters were quickly assembled. The layout was so standardized that a soldier could find his tent in a fort he'd never seen before. Final touches: gates were fortified, and watchtowers were built. Some camps even had artillery positions for ballistae or onagers. While marching camps were impressive, the real marvels were the permanent forts, or castra. These were the anchors of Roman control in conquered territories. Let's take a closer look at these fortresses. Size and layout: a typical fort housed a cohort of 480 men and covered about 5 to 6 acres. Larger legionary fortresses could house an entire legion of 5,000 men and cover up to 50 acres. Defensive walls: the walls were usually made of stone or turf, depending on available materials. They were typically 3 to 5 meters high and 2 to 3 meters thick. That's some serious protection. Gateways: most forts had 4 gates, one on each side. These weren't just openings, they were heavily fortified and often flanked by towers. Internal buildings: inside, you'd find barracks, granaries, workshops, a hospital, and even a bathhouse. Yes, you read that right, the Romans liked to keep clean, even in the middle of nowhere. Headquarters: the nerve center of the fort was the Principia, where the commander's office, administrative areas, and often a shrine to the imperial cult were located. Want to hear something crazy? Archaeological evidence suggests that some Roman forts in Britain were built in less than 8 hours. That's faster than most of us can decide what to watch on Netflix. Now, you might be wondering, how on earth did they build so quickly and efficiently? Well, dear viewer, the Romans had a secret weapon: standardization and prefabrication. Every legion knew exactly how to build a bridge or a fort because the designs were standardized across the empire. It was like ancient Lego, all the pieces fit together the same way, no matter where you were. But it goes even further than that. The Romans were masters of prefabrication. They would often prepare building materials in advance, ready to be quickly assembled on site. Imagine flat-pack furniture, but for entire buildings. This standardization and prefabrication had several brilliant advantages. Speed: as we've seen, it allowed for incredibly rapid construction. Efficiency. Every soldier knew their role in the building process, minimizing confusion and wasted effort. Adaptability. Standard designs could be easily modified to fit local conditions without starting from scratch. Easy repairs. When parts of a fort or bridge were damaged, they could be quickly replaced using standard components. Familiarity. Soldiers could navigate any fort in the empire, as they all followed the same basic layout. The Romans didn't just rely on manpower, they had an impressive array of tools and machines to aid in their construction efforts. Let's take a look at some of these ancient engineering marvels. The chorobates. This was a sophisticated leveling instrument used for ensuring that aqueducts and roads were perfectly level. It was essentially a long wooden beam with plumb lines at each end and a water channel on top. The groma. This surveying tool was used to establish straight lines and right angles, crucial for laying out forts and roads. It consisted of a vertical staff with horizontal cross pieces from which plumb lines were suspended. The libella. Similar to our modern spirit level, this tool was used for checking horizontal and vertical alignment. Cranes and lifting devices. The Romans used a variety of cranes, including the trispastos and pentaspastos, capable of lifting heavy stones and timber. Water-powered sawmills. Yes, you read that right. The Romans had water-powered sawmills for cutting stone and timber, greatly speeding up the construction process. These tools, combined with the Romans' advanced knowledge of geometry and engineering principles, allowed them to construct buildings and infrastructure that have stood the test of time. The impact of Roman military engineering extends far beyond the ancient world. Many of the principles and techniques they developed are still in use today. Road building. The famous Roman roads, built primarily for military purposes, laid the foundation for modern highway systems. Surveying. Roman surveying techniques formed the basis of modern land surveying. Concrete. As mentioned earlier, Roman concrete was a game changer, and we're still learning from its durability. Urban planning. The layout of Roman forts influenced town planning for centuries. Standardization. The concept of using standardized designs and prefabricated components is a cornerstone of modern construction. So there you have it, folks. From the mighty bridges spanning treacherous rivers to the fortresses that secured an empire, the Roman army's incredible feats of engineering continue to astound us to this day. These weren't just buildings and bridges, they were the sinews and bones of an empire, allowing Rome to extend its reach far beyond what anyone thought possible. The speed, efficiency, and durability of Roman military construction played a crucial role in the expansion and maintenance of the Roman Empire. Next time you cross a bridge or see a fortress, take a moment to appreciate the ingenuity of those ancient engineers. They may not have had smartphones or power tools, but they certainly knew how to build things to last. The legacy of Roman military engineering serves as a testament to human ingenuity and the power of systematic thinking. It reminds us that with careful planning, standardization, and a dash of innovation, we can overcome seemingly insurmountable challenges. As we face our own modern challenges, from infrastructure development to space exploration, perhaps we can draw inspiration from the Roman legions. Their ability to standardize, innovate, and adapt allowed them to build an empire. Imagine what we could achieve by applying those same principles today. If you enjoyed this deep dive into Roman military engineering, don't forget to like, subscribe, and hit that notification bell. And hey, why not share it with your history buff friends? After all, sharing is caring, and knowledge is power, just ask the Romans.